work session. It's 12:15. And we'll start off in the agenda. We're going to move to Luke and John on their presentation. So the floor is yours. Luke.
All right. I'll try to keep everyone awake with the food in their stomachs here. So we just gave the FEMA, had a good conversation with Greendale and Lawrenceburg and how that might affect this part of the presentation. The bulk of it is the Lawrenceburg, what's needed for the 100-year and for Army Corps, and more details on what we're recommending. And ultimately, we want to go to the Corps with your blessing. So it's unpacking that more, jump in with questions as we go. And then we have a schedule, and we already talked about it would change a little bit with the FEMA, how that might go down, and grants and all of that, but it at least gives the general dynamics of how that would play out. All right. I don't know why this isn't working. Oh, there we go. Pressing the wrong button. The first 2 or 3 slides I'm going to brush through. We know it all, but just to refresh everyone's memory, we got engineering problem, criteria, what's the solution, right? So what's the problem? Many different ways levee can fail. We're talking about seepage, backward erosional piping, sand boils. With sand boils, we're looking at 2 criteria, right? The first is it's all about a ratio between the groundwater pressure head and the clay thickness. That's when you boil it down effectively, you can think of it like that. And then also there's a certain offset from the toe of the levee that you have to look, and that offset can change depending on the geology. All right. We talked about this. Some of these slides I presented in December. I've added to them and modified them slightly. This is what our model was telling us a year ago when we had some of the preliminary inputs into it, and we were just seeing this is a factor of safety map. I don't have a legend on here, but the point of it is red's not good in terms of seepage stability. Blue is good, right? And there's some shades of in between. We don't really care about, in terms of levee stability, we don't care about what's going on in the middle here. So you kind of look at the edges of where the top of levee is there. And you can see this is quote unquote the existing system. There's a lot of red in the north, right? So that's why there's going to be some north solution. And then in the last 4-5 months, we've revised this model and we've updated some model parameters. There were some details in the model that we needed to circle back and dig deeper in the technical world, updated those things. And this is the top of levee over here. The point is that a lot of the red has shrunk for the top of levee. And this is the 100-year. So you still have red for the 100-year, especially close to the toe up here in the northwest. Maybe a little bit down here. This is where the pump station 1 and 1A are. Tate Street down here. Just depends on, this is the offset line. I put 2 lines here because that's one of we're still looking through the geology of all we have lots of borings on the north slope. So we have to look through the data there to hone in on what the offset is. So there's some shade, we're still fussing with where that line is exactly. But the point is, this is the existing conditions model. And what does that mean? It's my bullet point number 3 here. That's all of the wells that we've found and that we have rehabbed and that are connected to the system, so to speak. But it's the question is, and that assumes that they're all functioning and cleaned out and everything. This is what the existing conditions would be if they were all cleaned out. So the upshot is, even for the 100-year, you still need to do something with the existing cleaned out system on the north slope, for sure, and possibly down here in the southwest. Okay, for the Army Corps, definitely. And for the Army Corps, you might even have to do a little bit over by pump station 2, and then maybe up here in the northeast. Okay. But the one question here is, are all the existing wells clean and functioning? So we've done, well, here's a map. We all know this, but all these blue dots and some of these different colored dots are all of the wells. So you can kind of see you have a lot of wells, obviously 163. At one time, there was 173. Some of them were removed for the event center. Some of them have been permanently abandoned and that kind of thing, or lost. But 163. Okay. So we've done 2 rounds of rehabilitation. And traditionally, Army Corps, the way that they evaluate if a well is good or not, you just get your baseline test when you install it. And you basically compare it back to when it was installed. How well it's functioning compared to how it functioned when it was installed. We don't have that original test, right? So in 2014, 15, we went through and rehabilitated and tested all of them. And then we went back in 2018 and tested and rehabbed another set of 40. So then based on that set of 40, we have 2 rounds, and we can see how they degraded over a 5-year time period, 4 or 5 year time period. And we can discern better, like, is this a good well or is it a bad well? Because another question could be, well, maybe it's a good well, but it's screened in the clay layer or something like that. Anyways, we were able to discern, doing all these analyses of this subset of 40, which we rehabbed twice. 18 looked like they were in good condition. 16 looked like they were in bad condition and they would need to be replaced. And then another 6, it was kind of indeterminate. You would need to rehab it again to just get a final determination, is it good or not. So 18, 16, 6, about 50-50, more or less, of wells that were good and wells that were bad, and that's the subset of 40. So if you extend that to the remaining 120, maybe you might expect about 40 or 50% good, 50% bad. Anyways, the point is they're not all in perfectly working condition. So you would need to replace. So long story short, two takeaways from these last 2 slides. You're going to need to do something on the north slope regardless, even if all the wells were cleaned. And we know that at least some of the wells are not in working condition. So you're going to need to replace those, right?
And one more thing I would add to that. The ones that are good need to be rehabbed often.
Right.
We can't wait, 20, 30 years. Every 5 years, you're kind of stuck in kind of rehabbing that to maintain that they're good.
Right, because a lot of those are the 3-inch wells that were installed in 44.
Would that also not keep the cost down compared to waiting those 20 years to do something?
Right. Well, it's expensive to do this every 5 years.
Right.
So there's an O&M cost that keeps adding up every 5 years versus replacing with a larger diameter well that doesn't need to be rehabbed.
Then wouldn't that cost be higher than the O&M that we've done?
Replacing?
Yeah.
Yes, replacing would be higher.
If we waited to 20 years to just replace, all that maintenance we've done up to that point would still be cheaper than the replacement, correct?
We have to do it for 60, but we got to keep doing it.
I understand, but
Well,
my question is, if it's not any cheaper, how do you
Just
bet?
go ahead and put in,
so, yeah, and sorry, didn't.
no, I was just gonna say, go ahead and put in a new well.
Right, so one thing about the rehab is you're required to test it, test the wells, but you don't have to rehab them if they don't drop below 80% of what it was 80% functioning of what it was when you installed it. So, if you have these larger, newer wells, the likelihood of them dropping below that, the thought is you can prolong the time frame of the life of the well when you need to rehab it. And then if you rehab it and it doesn't get back to 80%, then you have to replace it.
Luke, I was gonna ask, over the 10-year project plan or whatever, plan project for replacing these wells, are you still gonna have to clean the existing wells along that time frame? The ones that haven't been replaced, to that
Right.
point?
So that's a really good question, and it kind of gets into the whole timeline of FEMA and Army Corps kind of thing. If you don't mind,
No, go ahead.
I think we can
I'm
answer
okay.
that or talk through that in the next few slides.
Before you move on.
Yep.
So you used 2014 data after you cleaned and rehabbed the wells. You tested them, you got a baseline for each of the 40. And 5 years later, you're saying 6 of them, well, you're saying 22 of those were performing worse after just 4 or 5 years. Is that correct?
Not quite. I don't think.
There's some nuance there, but and
They were
it's
all
listed out in
rehabbed.
our conclusion of this 18043 report. But if I recall, it was generally we had several shades of gray in terms of the classification, and that was the overall summary. If it was a good well, it fell into kind of 2 categories of like, we tested it and it seemed to be flowing. It was flowing. And then in 2014, we tested it, we rehabbed it and tested it again. So we saw improvement. And then in 2018, we saw that it went down. We tested it, we cleaned it, and we tested it again, and we saw improvement. And both of those together, we saw improvement, and we could determine that, yeah, it's flowing. It's clearly flowing, and we saw improvement. A lot of the bad ones, we tested it in 2014, cleaned it and tested it, and it looked like it wasn't really flowing, or maybe there was a low hydraulic conductivity of like the formation around it. And then we tested it again in 2018, and it had gotten even worse. And maybe we cleaned it, and it still was like worse than.
So they weren't all good after cleaning in 2018 or 2014. To start with.
Weren't all high producers, right? But we didn't know at that time whether it was due to the fact it was in a clay deposit or sand deposit.
Right.
It might have been a good well, it's just that there's no water there because they screened it the wrong depth.
Were they all
But
gravel packed wells?
they had in the old 3 inches, they have gravel pack around the pipes that have holes drilled in them.
Right.
So yeah, there was a gravel.
Yeah, and in 2014, we did have a rating table of all of them, and we rated them. So we have that quantification. What we saw in 2018 was when we did the second, there was some uncertainty in that first one, because if you could tell if a well was good just by testing it, they wouldn't need to just use, Army Corps wouldn't use that like baseline original test. That's the best way to determine how the condition of the well. So when we went back in 2018 and we had 2 tests, we were able to determine, like, I think a lot of what we were thinking were the good wells and bad wells was reaffirmed, but some of the wells that kind of looked like it was like, what do we do with this one? It's in between. It helped us discern better if it was actually good or not. So it was.
Let me ask you, Luke, so I'm gonna call a new well a 10.
Yeah.
So I'm gonna call that bad well a 1.
Right.
I'm a little confused. Is my good wells a 10?
Right.
Where would you throw them at?
Yeah. So what I would say.
Go ahead and I'll tell you what I think too.
Yeah. For example, I'll give you 3 short examples. Example number 1, the wells by Ivy Tech. They were installed in the 2000s, I believe. They replaced a 3-inch well with I think an 8 or 10-inch well. And wells 92 through 100, right? When we went in there in 2014, we cleaned them, and our specific capacities, they were flowing, and they looked pretty clean to begin with. Cleaned them, and they were still flowing. And then come back in 2018, and we looked at them and tested them, and they were flowing. And we didn't rehab all of them in 2018. We only rehabbed a subset, but we tested them all. So those were like good. They were clearly flowing, and they were clean before and after in 2014, and they were still flowing in 2018. And so in our report, we said, hey, it looks like if the well was clearly good in 2014, a lot of them were still good in 2018, so you can probably postpone the rehab cycle beyond the 5-year cycle or whatever.
But you're talking about wells that are 20 years old
Yeah.
compared to wells that are 85 years old.
Right. So a lot of the wells that were installed in 1949, which were bigger, again, I think they were 8 or 10 inches plus a bigger gravel pack. Those were installed in 49. Some of them have been lost. But those were flowing. Those were flowing in 2014 and 2018, but they were clearly more degraded than the ones that we saw by Ivy Tech. I have to go back through. I think some of those might be the good ratings.
So
And then
a good well, it's 85 years old, might be rated a 3 or a 4.
Yeah, there would be 10. They would be, they would probably start out if we cleaned them, maybe a 3 or 4, and then you rehab them and they get 5 or 6.
Right, and so then the 3 inches are where you really start to see a lot of the bads. And what you see in some of the bad ones is that, well, in the good ones in the 3 inches, what the pump that we could get in there, it could handle it. There wasn't much drawdown. Now there might have been drawdown, and then we cleaned it, and we have video of the wells too, so you can see the holes that are clogged. You clean it, go re-video it. You can see that they're cleared out. You can see prior to the rehab, it would draw down quickly. After, it wouldn't draw down as much. But the ones that didn't flow for the 3 inches, you would get this massive drawdown and the well would go dry, so to speak. So it was very clear. And we could see improvements each time, but when you can compare, you can kind of see, okay, yeah, we're rehabbing and it's not making any difference, or we're rehabbing and it made a difference. Sometimes it was bad, cleaned it, went good, went out there again, it was bad again, cleaned it, and it got good again. So we did see that.
So in a big picture, 50% were bad after we cleaned them and rehabbed them, and they weren't flowing enough. We went ahead and did it again, rehabbed. They never got great.
Right.
Some of the ones that are 3 inch had flowing going on, had a lot of effort to rehab them, and then 5 years later had degradation, had to rehab them again, but then they recovered about to a 4 or 5 versus a 10. In other words, the upshot is you're gonna have to rehab them every 5 years. You prove that some of these, the small ones, you have to rehab every 5 years, because when the degradation goes down, our model says we're not protected. The model assumes you're at a certain level. So unless you do this every 5 years for those, you're gonna have to they're gonna be degraded over that time. So basically 50% bad, period. 50% we could leave them in, but it's just gonna take a lot of rehab every 5 years, even for those good ones. Whereas the larger diameter, we're at least going 10 years and
Well, they have appropriate screens.
Yeah, they've got screens, right?
Yeah.
So anyway.
And so that good conversations, good questions, and it kind of feeds into this is the reasoning here. All right, so we know we need something, even if the existing system was functioning and everything on the north slope, right? We know we need something with that berm and some additional pressure relief on the north slope for the 100-year and for the core, regardless. And we know that there's a subset of wells that are in bad condition, right? So no matter what, you're gonna need something on the north slope to get to the 100-year and Army Corps. And then for the bad wells, you're going to have to replace those. So you could go out, and if you went out and replaced a 3-inch well with a 10-inch well just blindly, kind of like what happened to Ivy Tech, where they just replaced each 3-inch with a 10-inch. Well, our models are showing that they don't need all 10-inch wells right there, and you're just going to flood your system, right? So for the wells that are bad and you go and replace it, you want to fit it into this master plan, so to speak. You want to have this overall vision of this is where we're going, because eventually one day you're going to have to replace all the wells, even the wells that are good. So you want to replace it strategically so it fits into the overall plan. You don't flood out the city. So those are the two principal thoughts here. You're going to need something on the north slope regardless, and you want to have a plan. And this is the plan, the master plan of what you're replacing the bad wells and what you're marching towards.
And
Right.
just to make it a little clear about flooding the system, we want these to operate enough so that the whole city's safe, but we don't want to operate so well that we flood and we need another pumping station.
Right.
We're pumping too much water. We don't want that. So that's it. And when you do that, you're also investing in too much well. You don't need that money. So
Right.
the idea was to do this such that you could figure out the replacement scheme long-term in a plan and maybe increase the spacing in some areas to still be good, but not necessarily, we're not going to replace everything well. Anyway,
Right.
go for it.
And so here we are now, and there's discussion here, but these are some thoughts here that we're laying out in terms of our recommendation. So when you're replacing these, you're going to work towards a long-term plan regardless. So you're going to need that plan, right? Even the good wells, except for subsets that were installed in the 2000s, but a lot of the good wells are the 3-inch that they're 80 plus years old, so higher O&M costs. You're going to have to replace them soon anyways. So there's going to be short-term spending regardless. And also, let's say if we wanted to just replace the wells we needed for the 100-year Army Corps and rely on some of the existing systems, so to speak, just replace the bad wells and fit it into the overall plan and just do the north slope and rely on some of these existing wells that are still in good condition, well, you're going to have to, they're due for a rehab cycle here, right? So you're going to have to replace the bad wells. You're going to have to do something north slope. And if you wanted to rely on some of the good wells that to get to the FEMA and Army Corps, you're going to have to go out and rehab them again or test them and rehab a large portion of them. So there's going to be short-term spending regardless. You can't just sit here and, there's going to be, so anyways, piecing that all together, there's going to be short-term spending regardless. You got to fit it into the master plan because you're going to have to do work here. And so that's where we're at in terms of this grant is you're going to be spending all this money, spend towards something because these wells that you're just kicking the can down the road, so to speak, and you're going to be spending money doing that. So that's where the grant comes in. And then what we've laid out here is recognizing that depending on how things play out with the grant discussions and with your financing and all of that, I mean, the nice thing about Lawrenceburg's fixes are that you can do it in phases, so to speak, as needed. You want to go for it all because that's where you're marching towards with the grant, but maybe the grant comes in chunks or not, and then you got to. So we're just kind of laying out, this is the overall plan, and then this is how it could be broken up. And we'll share some more of that here. But any questions at this point?
We're still gonna get certification if we just leave some of the good wells in and we spend the money every 5 years to rehab. We're still gonna be able to get a certification package.
Do you want to do, this is what we're asking you.
Oh, I know, I'm ready.
That you cut to the chase here.
We gotta cut to the
And
chase.
the
I'm
chase
with you.
is-
I'm not in a hurry.
The chase is,
I'm not in a hurry.
will we
You guys are
certify?
convincing my board that we rehab good wells.
Yeah, and that's a bad, it's not correct quite.
Why are we calling them good wells then?
Because.
Let's think of another name here.
Yeah.
Average,
Not
It's
average.
confusing.
Well, I think, I just,
Functioning wells, but poorly producing wells.
Okay,
because we've got to get around to, what do we need to do
Yeah.
to get FEMA certification?
Yeah.
And move on to the Army Corps of Engineers. I think this is great information,
Well-
but you're guiding this ship. You
Yeah.
need to tell us.
Yeah, what we're saying, the plan we're going to show you is what we recommend. We
Okay.
do not recommend salvaging these
Okay.
3-inch wells.
Good enough, I
I
think,
mean, that's because
someone
we
else
think,
jump in, I'm good with that.
we think you're gonna spend more money
Okay.
and energy to prove that they're good enough, whereas you have a plan to replace them in a sequence, you know that you're gonna be good. So what our recommendation, long-term, is to replace the wells with another set of reduced number of wells. So that gets you the next 50 years, with lower O&M, extended rehab in between, that will do the trick. So, I mean, that's really it. And, because you have so many wells, there's so many thousands of combinations we could do an analysis on. Oh, what happens if we left this 3-inch well, et cetera? You're gonna be spending more time dealing with poorly performing 3-inch wells versus putting in one well that may satisfy 3 wells and building on.
That's what it is. You'll spend a lot of time and energy and investment into cleaning out poorly performing wells or 3-inch wells that need to be rehabbed often. Plus, there's a large chunk that are just straight up not flowing, period. So you're gonna have to replace that anyways. Well, you put a 10-inch well there, you don't need the 2 wells next to it. So you're marching.
But those 2 wells or 3 wells have to be removed or
So, and that's
closed or?
great. Yeah, that's what we have to, when you add a well, if it's not functioning, you got to decommission it. And that's part of, Army Corps 408 kind of thing too. But, if by chance, if this was phased out, and let's say there was a well that's flowing here and there's a well that's not, and we put a new well in here, let's say, you don't want to have, that's something, you don't want to flood your system and just, putting all new wells in and leaving all the old ones that may still be flowing. You might flood the system, so to speak, So you would.
So part of the plan is to
Yeah.
remove or
Right.
decommission or
Right.
whatever,
Yes.
the 3-inch wells, yeah.
Do you have an exact number? Like, we know how many wells we have now, what, 130?
We got that on next.
Yeah,
slide.
163, we can get into that,
You're gonna tell us what that goes down.
We'll show you that actually our spacing where we think they're gonna go,
Yeah.
plus or minus.
Yeah, so we can get into that now,
Okay, thank you.
Old system, there's 163, there were 173 at one point, 163, so there were 114 on the west, east, and south, and about 60 on the north slope. With the new system, it's about a 1 to 3 replacement on the west, south, and east. And then you need about the same number on the north slope, and they're gonna be larger wells, plus the berm. This,
Meet the top of levee situation.
I can kind of zoom in here, but the point is, this is the existing system with all the black dots. And those are all the existing wells, the original system. And all of these symbols, it's the new layout here. I don't know if you can see that over there, but you have it in front of you too, right? So what you can see here on the west, south, and east, they're just wider space. They're 10-inch wells so they can draw it down more. And then on the north up there by the tanks and the school, which is the major problem area, is really tight spacing. And then on the northeast there in the pond area, there's another little spot there where we had to take the wells off the toe of the levee too for the offset. That's it. There's a few symbols here. We can get into it. The blue are all new wells. The triangles The red, what we have in there now, there are wells that were installed in the last 10 years during all of these investigations. So one of them's been connected, and then we just have to connect the other ones, but they're already there. And then over here by Ivy Tech, those were newer wells, and they were installed, I think, in the 2000s. They didn't need as many there. It was overkill, so we could actually decommission some of those so you're not flooding out your system because you just don't need that pressure relief there.
And those were 8.
I forget. I think they're 8 or 10. I forgot off the top of my head. They're the larger ones, but they appeared to be in good condition.
Producing too much water. We don't want to build yet another pump station.
And that's those 3 pink ones.
Yeah.
What's the engineering cost, this phase and the north slope wall that we're discussing? What's our cost in engineering?
We got a spreadsheet
Okay.
for that. We can get to that on each one. We've got an estimate anyway. To be honest with you, that's what this year's cost is going to be mainly about, right? Because this is the
The
engineering.
engineering for it.
Getting the model for this, and then the actual construction documents
Is another.
that's part of the grant package and everything.
We'll
Yeah, but these costs are, we'll have this laid out. So, all right, there's a lot going on here, and we're not going to get into the details of everything. I just want to point out a couple of things here, just so you can get a feel for some of what we were looking at and everything. This is just the north slope, right?
slice through it.
This is a slice through the north slope. This is the existing up here. All these black lines are the wells on the north slope, right? So it's 100-foot spacing, and then the MGP well here, and then this is by the school, and they went down to 50-foot spacing, 3-inch wells. This red line is the top of levee, Ohio River, right? This orange line is the top of ground surface, and the bottom of the clay layer. Okay. Anyways, the ground surface is here. What we did in our calculations, we could say, without any relief wells, we have the Ohio River here, the clay thickness here. What level do we need to bring down the pressure to get an okay factor of safety? That's what this gray line is. The gray line is the level that you have to lower the groundwater pressure to. And last but not least, it's the dark blue line. That's what the existing system, it's lowering it to that level, right? This is just at the toe of the levee. Okay, so just looking at this, the toe of the levee over here in the northwest by the tanks, you can see these 3-inch wells are not lowering it far enough, right? Now they tightened up the spacing in the 40s, and it lowered that pressure just below the factor of safety. Okay, now down here, it's the same thing, but the new layout. And we tightened up the spacing and also have wells offset, so it looks even more crowded over here in the northwest. We have much wider spacing in this portion, but they're 10-inch wells, so they reduce that pressure even better. So they actually get it below the gray line in the middle here, even though it's much wider spacing. Over here, there was that ponding area, and there was another problem area, so we have more wells offset. We lower the blue line. Now, this is just at the toe of the levee, right? So 2 things. One, this is some of the process of the new design, right? We didn't just blindly pick wells, but we knew this gray line, and we said, okay, we have our chart over here. With this type of system, we need to lower it 20 feet. If we choose this size of well and this spacing and this penetration, this is how much relief we get. And so we can, that's kind of the initial starting point of the design process. The other thing I might mention is you might be looking at this and saying like, well, this is overkill. That blue line's well below the gray. Well, this is just at the toe of the levee, especially on the north slope. The issues were beyond the toe of the levee. So at the toe, it's fine, but we had to lower the pressure to get beyond that toe of the levee. Some of the other points in the levee, it's much closer to that gray line because there wasn't as much issue beyond the toe. Okay.
So, Luke, the slurry wall, where's it?
Right. So now we've revised and we're looking at that berm situation, the landside berm.
Okay.
But it was this area is where it's going to be.
Okay.
Yeah.
One thing I'll say, just for people who've lived the last decade, when wells were proposed a decade ago by Thalen, there wasn't all this detailed analysis, and they were simply just saying, we got 30 wells, they're all the same. We're going to use this spacing, we don't know, it looks, like this. And the Corps came back and said, you haven't proven you know what's going on. You haven't really shown this analysis that says you're just arbitrarily replacing your old system with a new system. So this has allowed us all along, I don't want to steal your thunder, Luke, but that map you had, every one of those wells were placed in a strategic best place. A longer distance between the wells, and also, that area needs a little more attention. Let's put the well right there. So that's the good thing about having this. We're able to analyze that and strategically just place these exactly where they need to be. And also on the north slope, Luke will talk about, we can keep taking wells on and off and testing all the hypotheses in a matter of minutes now. Like, okay, this is going to be the optimal spacing and location around the tank farm and that northern slope. So anyway,
Obviously, wouldn't that new system decrease the upseepage also
yes,
Right.
significantly?
yeah,
Right.
because you have just what you need.
Right.
And yeah.
And we're looking at the design standards to make sure that you get the pressure relief you needed. But also it's in the interest of us and Army Corps to see how it compares to the old pressure relief. Is it, reducing the seepage at least to what it was previously functioning as? And just looking at this, you can see there's more pressure relief, so it's as good or better. We have another map to talk about that.
One thing I want to bring up, you mentioned Thielen's report, but Thielen's report also was not replacing anything.
No.
They were adding.
They didn't.
So they didn't have any plans on any abandonment.
Yeah, they didn't have a concept at that time about what that would do to your pump station.
Exactly.
You would have needed a new pump station with what was designed without taking those wells out.
Yeah, they didn't even do any analysis of the existing system or the pump station is added.
Right.
Pump station.
Is the lower orange line the bottom of the clay?
Right.
And then what are the purple X's?
Oh, yeah, I have another secondary axis. That's the flows coming out of the wells.
How much CP come out of each well?
Yeah, so how much seepage, and I cut it for the purpose of this conversation, but as you can see, you have more wells here, but they're 3-inch wells, so it's restricted, and then there's less wells, but you have more flows coming out of each. So when we tie it all together, we have to look at that too, since we are using the existing pump station capacity. We don't want to have a significantly more amount of overall seepage coming out of these wells. So that's something we have to consider as well.
Okay. This is the most confusing plot.
Yeah.
Sorry about that, but it is.
There's a lot there, but
We say it's the best plot, but it's also the most confusing.
so again, looking off the toe of the levee, this is the new factor of safety map with the new relief well systems, but not yet including the berm. So if you just did relief wells, and and that white line, this is for the top of levee. It might change a little bit. We're still working on getting that exact location of the white offset, how far off the toe of the levee you have to look. But in general, you see the new system, again, red's not good, blue's good, and there's some shades in between that. But the new system's good everywhere for factor of safety for the top of the levee, except this north slope here, this northwest corner and it's that ponding area right next to the school. And the tanks, we added enough to push that red far enough back. But those tanks too, we had, that's why we had a solid line of 50-foot spacing wells on that northwest. This ponding, we might need to add another well there, but it's right there for the top of levee. That still could be good there. Anyways, so that's for the top of levee with no landside berm. It's flipping between the top of levee and 100-year. So this is 100-year top of levee, 100-year top of levee, 100-year. Okay. Point of the story is you still have issues with that little ponding area up by the school, but everywhere else you're good.
And that's where the berm is going.
Right.
Okay.
That's where, exactly. So kind of what we talked about here, how does it compare to the old system in terms of overall pressure relief? Again, I don't have a legend here. It's more conceptual. The point is we were checking what's the pressure reduction going to be in the new system versus the old. And the new system as it is right now, the places where you see red and orange, so basically just this corner over here, the new system actually won't relieve the pressure as much. Now, but everywhere else, the yellow, green, and blue, the new system's relieving the pressure a whole lot more. Yellow is 0 to 5 feet of pressure reduction. Green is like 5 to 10, and then blue is 10 and below. So we really had to bring it down for that northwest slope. So what's going on over here? Just that's one of the things we're looking at is, we might, depending on how far off we have to look in the northwest slope, I think we can probably pluck a couple of those wells off that northwest slope, and we might be able, and we're still looking in this area to make sure we got the right pressure reduction in this corner. So I think that's some of the stuff we're still working through is, this exact arrangement, a couple wells might move here or there, and this might end up getting resolved over here. But
where the boat's at, the orange?
the boat's like right here. Yeah.
Okay, yeah, it's okay.
Yeah. And why this is red right there, that's in 1949. They saw in the flood, there were sand boils, and it's over by the parking garage. And they installed, I think, 4 or 5, 10-inch wells.
And they're lost.
I think 3 or 4 of them have been found. At least 1 or 2 are lost. Yeah. But it's so far beyond the levee toe for levee stability, it's not an issue. But, we're still over here, there's that pond by the parking garage. So we're still looking at that, and we might end up adding another well in that corner, which might help kind of lower the pressure in that corner.
And just so you know, we're not as protective as the original, but it's still safe. And so when we go to the core, we're going to say, well, it's not quite as protective, but we've shown, here's our analysis, it's safe and it's going to do the job. And so that'll be the discussion with the core we have.
Right. And at the end of the day, it's off by 2 to 5 feet, which is still pretty close. But everywhere else, we're as good or if not better. Anyways, zooming back into that northwest corner, there's a lot of these upcoming slides are slides you saw in December. But I mean, we have this line of 50-foot wells, and it's just that ponding area, their clay layer is just so thin. So no matter how many wells we threw at it, you still have issues there. Here's our geophysics, just to kind of reiterate. We had a line right in it, and the clay layers, this pink, and the sand and gravel's here, and it just pinches away, and that white spot, there's almost no clay, right? So you'd have to reduce the pressure down to ground surface. And it's pretty close to the toe of the levee. So I was out there in April, and you can definitely see signs of seepage coming up. We've talked about this. What are our options? Relief wells, landside berm, cutoff wall. everyone has its pros and cons, or pumping. With the relief wells, we've reduced the pressure so much. Anyway, since it's such a localized area, berm is the least invasive option and is going to be the most cost effective. So that's what we're recommending versus the cutoff wall. Cutoff wall comes with, it's more expensive up front, and it comes with some other technical issues, getting into the toe of the levee and making sure it doesn't, it's more technically complex, so to speak, so you got to work through more in the design.
The utilities in there. So
Yeah, utilities.
But the berm is outside of our easement.
yes.
Our berm is outside the easement.
Yeah.
But
Right.
we can,
So that is one of the technical challenges
yeah,
with the
we're gonna
berm.
have, we gotta
Have
work
to-
on, we
yeah.
gotta work on that, which
Right.
we're working on, we're thinking about it.
Right.
And it's gonna encroach on our ponding area, so.
Right.
Exactly.
It will, yeah. Now, that's a good point, and we can talk more about that, but that ponding area is not, if we filled it all in, which we can get into, but, relatively, it might increase the overall ponding by no more than a foot. But, in that 5 to 8 inch range, but
Why couldn't we just dig out some ponding area
Yeah,
on the other
so-
side where the tennis courts are at?
We-
Take some,
yeah.
take the tennis courts out. and-
I did some kind of back of the envelope estimates, but there's some areas perhaps.
No,
Who's
but
a
we
tennis
can,
player, yeah.
well, I'm not gonna take the tennis, copy that. I'm just saying we could dig down, the ponding area kind of goes around it, doesn't it? So we
Right.
just excavate.
There's some areas I looked at, like what if we, carved out a little bit here, and you can
Right.
recover some of that. And also in our interior ponding model, we use the seepage model, and we knew we were gonna be revising it more, so we had some conservancy in there. So even with this new system, what we had in our interior ponding report were high numbers of seepage, and I think we're gonna be able to peel that number down. So we might mitigate the overall change from what the current map is showing.
What's the berm made of? Special clay, dirt? We can't take it from someplace and truck it up there, take it from where we need to get a little bit more of a ponding area and just move it over there and build it?
Probably not the right time.
Okay,
Yeah, we gotta make sure we have the right
okay,
mixture of soil things.
okay, that's good.
Yeah, and this is a general schematic. This is not for this situation. So this is just showing, you have your levee on the land side. You basically increase the clay thickness however much you need and however far you need it. This is a schematic, so it wouldn't be built up on the levee like this in this situation. Because this situation, this is just a general picture. We're not building another levee or anything. It's not going to be the height of the levee. It's just increasing it however much thickness you need. So in this modeling here, in the preliminary modeling, if we just basically fill that ponding area in with this berm, all we need is between 2 to 5 feet of thickness with all those relief wells, and you'd be good. And so you can get it down now that low ponding area is blue. It's safe there. So again, these are kind of pictures where I kind of drew in, I think, here. Because in the new plan, there's existing relief wells here, and we put new relief wells in right along that road. So the berm wouldn't need to really go up on that levee there, because it's really down into this ponding area where it goes into the lowest spots, and that's
So
what
you're not proposing to raise that gravel cinder road?
Yeah, I don't, no, yeah.
Okay.
Yeah.
This may be higher than that.
Just on the other side.
On the other side of the gravel road, because there'd be a line of relief wells, and we only need like 2 to 5 feet of additional thickness, maybe 2 to 6, but that's, it goes up from the bottom of that pond 4 to 6 feet, so it's good there, it's blue.
Wouldn't that be better for the schools, or, if they wanted to do something, no digging or anything, but couldn't they, now it's down like this and gets wet, wouldn't it give them more something?
It could.
Yeah.
I'm just saying they could use it.
With that concrete drainage ditch that goes all the way and
Right.
goes across, You have to do anything of that? You have to increase it, the width, or?
Right, so with what we've shown here, we would just be leaving that ditch
So
there,
it's-
because that, all that water, yeah, it travels through there, so you need to make sure that that remains. And,
But what I'm saying is, will that increase the flow in it?
so it won't necessarily increase the flow,
Okay.
so to speak, but the ponding elevation would go up just a little bit.
Okay.
Because
Where
again,
would it go up at? Because if you fill that area, it might make the area closer to the school safer, but it might make things over on George Street on the other side of 50 and right there, I mean, that area might come up.
It's gonna raise all of it up, some.
It'll raise it all up some, but it seems to me like
it's not, yeah.
Doesn't near your
Let me
house,
see
huh?
if I,
Well, I mean, you got
Oh, yeah.
10 feet over there, don't you? You got
I
a
did-
lot of area over there, really.
let me see if I, let me see if
I agree with you. Come on, that's-
I threw some power or figures in here just in case we needed to talk. But I think I grabbed some that could be helpful. And that,
I mean, suffice it to say, we need to kind of select that, how much more volume we need and where that happens, right? So we don't impact.
yeah,
Unless you have enough volume, if it goes farther over toward the back end of it.
Then it won't have any.
But the berm's also gonna reduce the up seepage.
right,
There's a lot of that there already.
right.
Yeah, you're absolutely right.
So,
I didn't grab the right one. Let's see here. Well, give me 30 more seconds. I'll show you something here. I think this is the one. Yep. All right. Yeah. So just with some initial estimates, if we were to fill that whole ponding thing in, which in the big scheme of all of the storage, it's not that much. And like I said, it'd probably in that 5 or 6 inch to 10 inch increase possibly at most. Well, this blue is the 100-year, right? And the interior ponding, and this orange is the 500-year. So there's about a 6 inch difference between those two. But you can see the difference in the orange versus the blue in terms of the area. It's not that much really. This is not part of the conversation, but so it might increase it just a little bit. And it would probably be mostly this area where it increases it, probably not so much here. It'd probably be mostly this area.
The water's getting down there and
Right. So,
Yeah, but that's all the elevation there, is up there.
so in terms of the overall area, I don't think it would expand things too much. Plus, there might be areas where you can kind of trim it back a little bit. And the last thing I might mention, we're working. Let's see, like I mentioned, 2 things that we're working towards here at the end. One, we're finalizing all our model, but we are also taking some time. Ultimately, it's in your interest because it could reduce the overall cost. But 2 things. One, depending on how far off the toe of the levee, we might be able to, or depending on how far off the toe of the levee, we might not need as many relief wells there on the north slope. So just, which would reduce the overall seepage, so you have more ponding capacity, so to speak. Also, it's an interesting thing, but depending on how far off the toe of the levee, you might not need to fill this whole thing in. Like you might be able to only come out probably at least to this point, but maybe you wouldn't have to fill this little corner in which case you could expand that channel out and gain some capacity there. So we're working through gathering all the borings and looking at the details there. So
Who owns that area? Where's the berm?
School.
School owns all,
Yeah, Jared's looking into it, or has.
has all that total area?
Yeah.
School owns it?
The school has it. So it's kind of one of those wild ones, so I don't get too much of the right of way. The issue is we don't have an easement on it.
Right.
That's the major.
If you add some additional including the berm area itself, but something that the school could use.
Right. It's unusable now. It might be.
It's unusable, but if you added a couple more feet, would that then be a benefit to the school
Absolutely.
to use as
Practice
Right.
a
field.
field of some kind?
Little tree cook.
And then that way, maybe they're more apt to help us
Oh, okay.
if we're giving them usable land.
If we have to go take and talk to the school, which depending on these guys' decision, is there a way for your computer, which you just had those ponding areas, and now all of a sudden you're gonna consider that area right there, we filled it.
We have to
Can
rerun.
you show the school and us
What's
then
gonna
how
be
much
impact-
that would grow instead of just saying, so can you picture that for us if we have to make a presentation and say, here's where the water will go?
Here's the impact of doing that.
Yeah.
Yeah.
We can do something like that pretty quick to get a good feel for it without running the whole interior
I'd like
model
to
again.
see that. I mean, okay.
Yeah, so talk about that. Yeah, so how this could roll out in phases, depending on
Now the plan.
the plan, right? We have this master plan over here that you're working towards with the berm and all of the wells that will need, you want to have a master plan to work towards, or if you get a grant for everything, just do it all now. I say, but if you need to piece it out for various reasons, this is what you would need for the 100 year, and this is what you need for the whole thing, right? And I think, I don't know if it's in these handouts, but at some point, this 10-year, we also demarcated, like, what if we engage in some agreement with MGP to turn on their pumping wells? Because that helps the situation. I didn't include that on this slide. It just gets too complicated, and that's a whole nother conversation. Anyways, on here is the 100-year without MGP pumping or anything like that. It's just the relief wells and the berm. And what you would need is you'd have to do the berm for that ponding area, and you just need 36 new wells. And as you would march toward that, you'd abandon 64 of the wells. Yeah, so 36. Oh, and the wells that have been installed in the last 10 years with these investigations, you just connect those. So you connect the wells that have already been built in the last 10 years. You install 36 more new wells, and you get the north slope berm. That's what you would need to do for the FEMA 100-year, and then you'd be good.
And how many wells would you replace per year on our plan?
So just broken out in 10 years, if you did do that, I think it's
It's in your,
I think it's 9
It's
wells
about
per
9
year.
wells per year, so that
Or divided,
36 means,
Yeah.
36 means we'd get there in 3 years.
right, that's what, you did it under cash flow
Yeah,
analysis, you.
4
At the
years.
end of
Yeah.
2030,
Yeah.
at the end of 2030, I think we would have a shot on the Lawrenceburg system of having a FEMA certification.
Right.
2031, is that what you said?
Well,
Maybe at the end of 2.
If you, 4 years, so
4 years.
if you started construction next year, 27, 28, 29, 30.
and that's us thinking that the planning would start, and then you're gonna get into a timetable here. Planning would start, conversation with the Corps of Engineer, back and forth, you two working together. Hey, looks like we got them on board. Let's decide, we'll put it out for bid, see what it's gonna cost, tighten up the numbers on the financial report. Once we know that, make another decision whether we're gonna start or not, when we can start.
Yeah, right now, it's kind of interesting that the timing coincides with the 2030 magical time that we could hear something about.
Yeah, it's just a good thing we've been doing the work we've been doing for quite a while, guys, because we wouldn't have had a shot at this if we wasn't doing what we were supposed to do.
But we still have to go to the, this all sounds good, but I mean, we still have to get the Corps to okay it.
Yeah,
Right.
and we'll touch.
Okay, I'm sorry.
Keep it going, but you're absolutely right.
I mean, we can think it's a great idea, but until we meet with them,
We don't know.
we don't know.
Right.
And how long is that decision gonna take them?
Yeah, so,
Let's talk.
yeah, we'll get there in just a second.
Okay.
We'll just finish out these last two slides and we'll just enter in that conversation. But this is more of just conceptual, you know, I told you, we're looking at the north slope. Also, you know, looking for potential cost savings for you, since our well spacing is so tight in the northwest. We might be able to drop some of those down to 6-inch wells, which would help. Because then you don't have as much seepage flows coming out of those wells, if we can do that, and it helps for your pocket, because it's not expensive to do 6-inch wells. So we're looking at some of that. Told you about this southeast area where there's the pond. We're looking at that again. And then, you know, there's a couple of spot areas we're fine tuning, and there might ultimately, you know, we're just that's what we're focused on right now. Those last few areas, gathering our models, and then we got to summarize it all in our report.
Does any of that help the distillery?
Proxima or MGP?
Either one, I don't know which is
MVP.
which, to be honest. with you.
Right. So just my initial thoughts here, up here in the northwest corner, I think at some point it's going to be really good to bring this to their attention, because we're showing right around. Yeah, you can kind of see like right in these areas here, even if we do line relief wells here, they might have some sand boils pop up around their tanks, and I think they probably want to know that.
I think we need to tell them, they don't,
Right.
we're gonna tell them.
We're going to tell them
Yeah.
for the levee stability, we're probably good, or we are good. But for their tanks, however, for their knowledge, we haven't included their pumping wells here. So that does help their situation, but they might want to look at that a little closer for their.
Yeah, but you can't put relief wells inside them.
Oh, yeah.
Pipes
No.
No.
Don't we have relief wells
Yeah.
farther out this way?
Yeah.
Yeah, they're,
They're out.
Oh, yeah.
right, we got relief wells.
Not right now, we don't.
Well, the
Oh,
new design, yeah.
The new design.
Oh, the new design.
Yeah, yeah.
Oh, okay.
And that's why we put some around here, and
Oh,
we
that's
might
right, that's right.
We might not need quite as many
Yeah.
around here. We put those in initially because we were expecting to have to look further out. But this line looks like it's going this way.
But putting those in would help them.
It would help them, yeah.
Absolutely would
Yeah.
help them.
That's
That's why having a
Yeah.
good discussion with
Yeah.
them, I mean, we've had a really nice interchange before, and I think once we get settled close, we'll go meet with them and talk about it. And again, this happens when the water level goes up to certain heights, so the good thing is we also from this know exactly where any weaknesses are, so when an event like this comes up, we know where to look.
Yeah. So that's the presentation here. I believe that was all the slides. Yeah, any questions? And ultimately, we just need, we want to set up a meeting with the Corps and say, hey, this is what we're seeing, this is the direction we're headed, even before we finalize the seepage report. So we want to make sure that you're on board with this plan before we go to them.
Wait, I'm sorry, you're not gonna meet with them, but we're not meeting with them till you get your seepage report done.
No, we are.
Oh, we want it?
Luke, we didn't have anything scheduled, did we?
I can pull it up here, but yeah, that,
So basically, we're saying, first of all, we've laid out what we think is a 10-year plan, getting to the FEMA level 4 years, 2030, which is about a good timing for a lot of things. And we want to now talk with the Corps about this plan, not getting final approval.
Oh, okay.
But we've
Oh, I-
been, but along the way, we've kept them informed with what we're doing with the relief wells, because it's very complex. Now we want to say, listen, here's what this looks like, what we're going to be proposing. Any thoughts do you have? Here's why we're looking at this, here's what we're seeing, and just getting their feedback. But we don't want to propose something where you guys say, no, we're not going to do that for another 10 years, or we want to do it all in the first 2 years. I think what we've laid out is the plan we believe will work. It'll be acceptable. It's something we can certify. It's going to get you to FEMA in a reasonable amount of time. And if given approval, we continue with the engineering and work this year to get us prepared to do perhaps a first phase of this in 2027.
Yeah, and to add on to that, we'd be saying to the Corps, this is the master plan, and this is what we're seeing is needed. And it's worthwhile to go to them now, just to signal to them, like, this is the direction we're headed, and to get any feedback from them saying like, yeah, that's good, or, oh, make sure to check this situation out here or whatnot. And then we finish the seepage report, including all of this.
So
And
my,
then-
For example, they, we mentioned the story well, and we haven't talked about it because we think we're able to do it without it. But I can bet you they're gonna say, did you consider a slurry wall? And of course we have.
Yeah.
So we'll talk through each of those.
so my question is, listening to this plan and knowing a little bit about it and sitting in on that meeting the other day, it sounds to me like the timing also would be, hey, we got our funding and we're back, so where are you guys at? From what I'm hearing, we're gonna possibly be able to hand them a certification package that will please them to the point where the Lawrenceburg levee system has a very good chance of getting certified for the FEMA 100 year. Am I right, or?
Yes, because by that time, the construction will have been completed. We might have some cleanup documents that we have to kind of as-built pieces, but yeah, I think there's a good, and knowing that we're shooting for our worst case, and it may be better than that, gives us confidence that we should be able to.
And in that period of time, though, we're not giving up on chasing the grant. We're still committed totally to those guys beating the bushes and looking for whatever they can find.
Well, here's where I'm a little confused, Steve. If we go through this plan that he's just laid out, what's our cost?
It's right here.
I'm confused. Somebody explain this to me. I see a
Well,
bunch
it's
of
figure
figures.
without grants, good.
Well,
With
without.
Without grants,
That's
it's,
without.
That's without.
you guys,
That's just us.
You want to go through it, or
Yeah.
well, I don't think you have that one.
I was gonna say, I could.
maybe I'm gonna have Luke just go through it a little bit, because I know it's been a while
See,
since I read
how
it.
we
Yeah.
fund that.
You want to pull up,
How can we
that
do
would-
that if that figure's right?
No, it's not 27.
Oh,
It's,
okay.
no,
That's what I'm
no, it's,
That's for the whole.
I'm trying to figure out.
Yeah.
If we say okay to this plan.
Oh, for
yes, it's
FEMA.
No, this is absolutely essential. We didn't get just to review the plan and how it rolls out, what the cost each year is estimated to be, what we're gonna end up with after 10 years.
Right.
because you've never really said how much the berm is yet.
oh,
He's got a.
yeah, it's,
Good number.
Correct. Can we circle back to something, the FEMA, as you guys said, FEMA was, they're looking at these two levies. That's one, correct? I mean,
for the
and
land process.
And the land.
Their evaluation is the same.
So, and we've talked about this, and I've brought it up before. If the Green Belt levy is certified, why is the North Slope even an issue?
Corps don't recognize the Greendale levy.
Not worried about the Corps right now, I'm worried about FEMA.
FEMA,
Okay, so.
well, first we need to know certified before we are, right?
Not yet.
I mean,
Not necessarily.
well, they have no money, they have no grant, you guys can go ahead with the plan and finish it and be FEMA certified before Greendale is even.
I know Paul raised the question, who's the money that we have to belong to? And I don't know what that answer is. I can't, I mean, I'm a representative here of Lawrenceburg. I feel like, yeah, that's where the money came from, but I'm also not somebody who has the ability to sit here and say, all that money's for Lawrenceburg, none of it's for Greendale.
Well, you could go, here, I guess we haven't talked about just in general. This plan gets us in 4 years to FEMA certification. What happens if you stop? At some point, the court's gonna come and say, you're not finished, you haven't protected to the top of the levy.
Right. But as
So-
far as
so, but- so-
mortgages and lending and insurance is concerned, aren't we only concerned with FEMA?
No, well, you're concerned with maintaining your approval from the court, because if you have an incident, they're gonna fix your levy and you're not gonna pay for it. So, yeah, in other words, if it goes above the 100-year and you have a problem, they're going to fix it.
Yeah, we want to keep our
The Corps has the appeal
500-year
84.
flood, or we want to keep that. We gotta be, it was built to the 500-year, we need to keep it that way.
Right.
And you know, Andy, your question though, when I think about whose money, I go back to the cost benefit analysis. This doesn't say whose money it is, but if their cost benefit analysis is 0.8 and Lawrenceburg's is 360 or 320, just good business decision, I would think. I'm not saying whose money it is, but I'm just saying that would be.
I don't disagree with you. that-
Okay.
that We have more of an obligation to downtown Lawrenceburg than we do to this industrial area of Greendale, no
Okay.
question about it.
Just,
And with that plan, we can get to the FEMA.
But my point
Or
is,
the old.
is I'm just bringing it up, that this North Slope work doesn't have to happen if the Greendale levy is certified.
No, it does, because
It does,
that
because
only,
we'll have
that
people
only
more.
satisfies us to the 100-year.
As far as FEMA's
As
concerned,
far as FEMA's
as far as the
concerned,
people inside
Right.
that levy over there.
which
keeping
means they would have
insurance-
to have that certified before we did to not deal with the North Slope. Yeah.
Correct.
hit the numbers, or while it's fresh on our mind, tell them what that.
You're right.
Yeah. Yeah.
If they were good,
Oh, yeah,
then we'd be FEMA, the North Slope would,
Yeah,
hold us from being FEMA certified.
you just look at the west, south, and east, and then for FEMA, and
For
then,
FEMA.
yeah, for FEMA, and then, and I know that's what your question is, but just to say, one thing I wanted to say, but I didn't get to here.
Don't have a-
With the Corps, there is.
I understand this is an Army Corps of Engineers levy. I understand that we want to keep that 500-year rating. I understand that will satisfy, we're going to have to satisfy that at some point.
Andy, can you repeat
I'm
that? I
sorry.
don't hear that. I'm sorry. I want you to repeat that. I didn't hear you.
Well, I'm just saying that I understand that it's an Army Corps of Engineers levy, and I understand that we want to keep it to the 500-year flood. But, no, it doesn't have to, as far as FEMA's concerned.
But FEMA has nothing to do with the Lawrenceburg levy.
We're trying to satisfy FEMA right now, aren't we?
Well, FEMA does have something
Yeah,
to
that
do with
North
it,
Slope
because
has
we
a
gotta
lot to
meet
do
their
with
standards on
FEMA.
100-year.
Right.
However, we're spending $40 million to certify the Greendale levy. We would have to spend that amount of money to certify the Greendale levy.
Well, I'm just trying to get to the point that if the Greendale levy was certified, then this North Slope problem goes away as far as FEMA certification is concerned.
I don't think it goes away, I just don't think it will.
So John, will,
That's
if
just me
that's
thinking,
true, will
my
you start,
thought
are you gonna be
process
able
don't
to?
mean nothing.
Here's the oddball thing, you know, we've got these divided up, JMT's doing Greendale, Mandel doing the other one. In order for me to certify that for Lawrenceburg, I would have to look at Greendale too, yeah. It would be odd.
There would have to be some joint, like,
Agreement.
no one's looked at that scenario, so to speak.
So you wouldn't be able to certify the Lawrenceburg levy until the Greendale levy?
He's saying he won't
System was-
certify the Lawrenceburg levy unless he's the one who certifies the Greendale levy too. That's what he said.
This is a
You're
case-
changing the whole dynamics,
Well,
that's for sure.
I think there has to be an engineer or a team of engineers that would have to certify both together.
Yeah.
So
If
if
that
you're
were the
gonna
case.
rely on Greendale, for Lawrenceburg North Slope, it becomes one system in the eyes of FEMA. And so there has to be there can be multiple engineer teams working on it together, but there has to be one package and you have to look at the whole scenario. So that's,
Whereas because we've always felt that is not gonna cut it, or else we would have just been doing FEMA all along. So
I thought years ago, this was like debunked. I don't remember the whole conversation, but I do remember it coming up, but I don't remember.
and one thing I was gonna say, and I know we're just talking about FEMA, and I know we are, for the PL 84, for Army Corps, if you're looking towards that. One thing I'm not sure about is, okay, if you didn't go for the Army Corps, or, it took longer to get there, you get out of the PL 8499, okay? The other factor, and maybe, this is Army Corps infrastructure, so to speak. So they might have a say in terms of what they think about that situation, because it's, at the end of the day, they built it, and that's why we have to go to the top of levy, because it was Congressly mandated that you have to do that. So there might be some further discussions there as to what the Corps would think of that if you wrapped Greendale into Lawrenceburg.
I guess here's a question too, and this is good to have this discussion, is that when we go in to talk to the Corps, we have this plan. This plan is really focused on Lawrenceburg. We're not even talking about really Greendale, though we'll acknowledge it. If we went in there and said, listen, we're gonna try to use all of our money to certify the Greendale levy. That way, the North Slope is taken out of this concern. How would the Corps view that, considering you're not meeting the 500-year flood? What's the consequences? My feeling is they would say, well, you're no longer in our program, and you're going to have to pay every bit of money if something happens.
Now, what are we getting out of being in their program?
It's an insurance policy right now. Insurance policy. I mean,
It's at least that PL 8499. So if there were ever a flood, and there's multiple things. One, you get their assistance, and if there is a major flood, they can come help support the efforts. One is just their technical interaction, like with their inspections and all that. Another thing on a financial basis is if there's a PL 8499, if there's a flood and the levee infrastructure is damaged, you can go to them and they'll have the funds to fix it. So
Here's another big thing. The money came to town in 95, 96. It was put in the checking account. The Greendale levy got built in 2005. There's no way you can convince me that this is Greendale money. No way. We have been doing our job, and we took it upon ourselves to take care of that levy, the maintenance of it. And our agreement in this book states that if there is a project, we are to tax the freeholders, or find another way to do it. So I don't think the money, in my mind, the money's not even a question. It's like if you're my neighbor and I got $2 million in the bank, but because I'm part of you, hey, you want me to take care of your property? I
don't disagree with anything you're saying, but I'm also saying that I don't think that any one of us is in a position, even as a group, to necessarily be able to make that call about whose money it is.
I think we may have to. So when you say we can, I say we may have to. Well, we're talking about fixing the Greendale levee so we don't have to build the berm you're gonna tell me in a minute, what's the berm cost? We'll say, let's don't make it up, I'll be too high, I want it to be low. Why would we gotta spend 40 or 30 million to save 2 million on that berm wall? I don't think the numbers don't jive for me.
I want to ask something before we get away from it too much. You said by going and asking the Corps that question, they may look at you and say, well, you're no longer in our program. Now,
Well, they wouldn't say it immediately, but they'd say that could be the
If your
impact.
plan is not.
but what I'm saying is, can you not present that question to them and say, we're just kind of asking here, it's not that we're gonna do it, but what's your thoughts?
That's the way I would do it.
Yeah,
So I would say, hey, we're looking at all options here.
Right.
As we're going through this, let's bring up this option. How would you guys view something like that? What are the consequences?
There you
Let
go.
them tell us and we can report back
That's
to
exactly
you.
right.
But these are not, I think these are really good questions to have this discussion. Maybe you
Well-
all have to affirm, no, this is Warrensburg's money or not.
I mean, I've heard it years ago, and I think it was answered, but I just,
Well, but I know where Paul's coming from, I know what the agreement says, and Lawrenceburg has been taking care of the Greendale levy for the last 20 years, as far as maintenance and all.
Absolutely.
The problem is, and the agreement states that there is a project, that's how you raise the money.
Or other sources.
Yes,
Make sure that's in there.
when, other sources, yes. When John said that he couldn't possibly certify the Lawrenceburg levy without the Greendale levy, if I understood right, to see what's coming in there, that may not happen for years. If we're depending strictly on, I mean, if all dollars for the Lawrenceburg levy in your plan comes out of our coffers, then Greendale's depending strictly on grant dollars to get anything done whatsoever, and we have no idea when that might possibly happen.
Yeah, you misunderstood.
Okay,
I said I couldn't certify Lawrenceburg if all of a sudden you said, guys, we're not gonna do the North Slope project because we're gonna
Come on.
send all of our money to the Greendale to certify their levy. Then I say, well, I'd have to look at Greendale's levy in addition to the outside of Lawrenceburg to certify. We can, in 4 years, we'll be able to certify this
I
levy.
misunderstood.
no, I
matter what
misunderstood
happens,
that,
you
right, yeah.
so I got a question, so on Andy's train of thought here. We would have to certify and spend the money on the Greendale levy, so that's an amount of money. But we can't just ignore Lawrenceburg, because we also at that point would have to certify from where the Greendale levy ties into the Lawrenceburg levy all the way around, right?
That's right.
So we're gonna have costs, so it isn't just a Greendale amount of money, we're still adding an amount of money to the train of thought,
Right.
I believe.
You would have that piece of those three sides plus Greendale's coverage.
Right.
I just wanted, there was talk about Lawrenceburg's money, Greendale's money, whatnot. I just want to reiterate that the lease is not Lawrenceburg's money. That is a private agreement between us and a third-party, non-municipal entity, the casino boat. Lawrenceburg's made that false claim several times that the casino boat money is their money. I think we've proven that we actually own the land, the boat, or where the casino's actually listed. We're allowing Lawrenceburg to take money. That could be all our land lease if we really want to come push to shove. Yeah, it wasn't a good idea back then. It's better to, it was a, when I talked to Richard Butler about it, it was a way that we could share in the wealth of doing this. And because we took that sucker, we decided to get rid of all of our special benefits taxes, which prior to that boat being there, that's how this levy system supported itself, was through direct taxation to all the freeholders. Now that was like the benefit to the freeholders, we go, we'll take this lease money, and that way we don't have to tax people on special benefits. So there is another issue though. So I just talked about the casino boat money. What about the money that was given to us when we split from Lawrenceburg? Now that may be another issue, okay? So
What's that?
so basically, we got money, right, when we left the city of Lawrenceburg. Lawrenceburg, we became a separate entity.
Also, Lawrenceburg flood control.
Right, they gave us some seed money or whatnot, and that question is, is that Lawrenceburg's money, that seed money, Lawrenceburg's money, and can that be spent? I would say that there might be some issues on that, but not the lease money.
How much is that?
I thought it wasn't, like 56 What was, I can't remember. It was a sizable sum when we split off. You remember, was it like
I
56?
know, I'm not sure about the
56,000?
split off, 56, no, he's talking
Yeah.
about millions,
Yeah.
56. You're talking about the initial, what Paul said, we got, I mean, there was a deposit, right? I wasn't here, but
That's not from the lease money though, is it?
no,
Well, when you own the property, you own the property.
Yeah, but that 56 million that Warrenburg gave us wasn't from the lease money, that was just,
We don't know.
Lawrenceburg gave us some money. I thought it was from the casino.
That's
so
what I,
if we got that 56 from the casino, then that's our money. I mean,
A doc knows all about that, by the way.
At this point, as a group, I guess what we're asking now is, do we want Lundell to go to the Corps, present all of this, and if we're headed in the right direction, do we then want to, as a group, give them permission to start engineering on these projects on the Lawrenceburg aspect with the earth berm and with the relief wells, to move in that direction?
Let Luke go over the numbers here, because I'm kind of.
Oh, yeah. Yeah, the numbers of, so let me just pull up, and I sent this over to Paul and Heather, and I think you incorporated into, yeah, that PDF. Let's just pull that open here. Is it this one? Yeah, this one. So this 27 million, that's okay, 23 million. And in the grant conversations, I think the number was 26 million. So 23 million is with the shift from the cutoff wall to the berm, and with a more refined number of the relief well. So what we were showing is it's going to be cheaper, this option, compared to what we have for the grant as a placeholder. So that's good news there. And then if you break it out over 10 years with interest, everything, when you add it all up, it ends up being 27 million. Yeah.
That's the whole deal for the Army Corps.
Army Corps and
So,
everything.
What about, just FEMA, where are we at with
Yep,
that?
let's go on
Are
to
we about
that.
$10 million?
I have a number here.
What is it?
For FEMA, it's, the total would be about 12.7, split out over 4 years.
Do we have that on our paper?
Let me see it. You might have to do the math here.
Greg, it's-
Addition in the first 4
you have to add them up. I don't think it's added up, is it, Heather?
No.
1,
Okay.
2,
Well, that's what Greg was looking for.
Yeah.
You're not-
2, 4, 6, plus another 6, that's 12.
Year two,
Yeah.
5, right?
2,
Yep.
5,
And what is
Two,
it total,
two.
Greg?
Oh, I don't
6, 5, 11, plus, yeah,
45.
know. 37.
12.5 million, so, plus or minus.
It's about 12.
12,
12.5.
153.
And that includes, let me double check this, that includes like the engineering fees and all that. The landside berm of that 12.5 million,
That's what I'm,
the landside berm is 2.4 million, and then all the construction costs, services, and engineering, it's 3.6 million when you add like the when you add in construction contingency, and then when you add in engineering,
What's the
at
contingency?
3.6 million.
yeah, what was the contingency? How many, what was your percent on the contingency?
So it's 2.4 for the landside berm, plus we put in a 25% construction contingency,
Wow.
and then a 10% engineered and permitting, and then 10% construction services.
But the 12.7 gets us our berm too.
Yeah.
That's not,
12.7
gets the berm, gets your new,
relief wells, the new relief wells, and the abandonment,
and the connection of the 8.
and the connection, all for FEMA,
Right.
for the north slope and everything.
That's over 4 years, 12.7 million with 20.
Right.
No, you go.
I was gonna say, if you present something to the Corps in the next 60 days, what kind of response time would you think you would get to know what direction, if you're headed in the right direction?
It's a good question. I think with the past, when we've been doing these, because we've talked to them about different topics, relief wells, et cetera. I think we were going into a meeting telling, here's our objective, here's what we want to try to get on you. I think we'll get some feedback even during the meeting.
Yeah.
They're not gonna necessarily put it in writing and say, we approve this. But I think we'll hear from them during the meeting that a multi-year plan is okay, your relief well plan looks good. What'd you do with the landslide berm? Oh, what else did you look at? Okay. I think we will leave the meeting with a general sense that it makes sense. They may have some additional questions that come up after that.
Yeah.
And maybe another 30 days after that or something,
Yeah.
but we're not asking for like a written formal approval, but we're
Right.
looking for the technical people to go, yeah, this makes sense based on what we've done.
And then face-to-face meeting, we're
Yeah.
going down that, we're meeting down there.
We'll spend the day down.
Yeah, I was gonna say, I'm not.
I think the Corps is very aware of the pressure that we're under. The Corps is, man, they've been excellent to work with. The only thing that might happen is in this, there's gonna be a whole lot of reviewing done here, because you've done a lot of work over the years.
Yeah, when
And
they know
they
that-
might make us pull a 408 to review, and we might have to pay a fee for them guys to review, just like anybody else would. That's a possibility too.
Yeah, we'll, in this meeting, we'll talk about our plan, but we'll also stack on top of it all the reports they're gonna be seeing from us and ones we already have, so.
Yeah, and then, so we'll get their feedback here, and then we'll finish out the seepage report in hopes that, you know, if they have anything like, hey, look at this, or look at that, so you can just wrap it into the seepage report here in this, July, September timeframe, and then it's in their hands, like, for review, for like actual review of everything.
So is that something you think we can get accomplished in the next couple of months?
No.
No, not, I mean,
No, he
going
means-
to them and
Oh.
Seeing,
requesting
yeah,
a meeting.
Yeah,
we were hoping to, I think we were talking about sometime in March.
Yeah.
Originally, but we haven't talked to them since, you know, government was closed down, you know, so we'll check, but we were hoping March, April, probably.
You mean just talk?
Yeah.
Yeah,
We're ready.
have a meeting with them.
Yeah, we're ready to go.
Direction.
Yeah, once we get the thumbs up from you guys, we'll email them and call them, you know.
And by the
Right
way,
after that,
we're all
just
gonna
says-
be at their meeting here coming up too, so that's another,
Be at the convention.
we'll talk at the
Yeah, we'll talk to
convention,
them.
hey, when we can do that, so it's a good time to go offline with them and say,
I think they're gonna work with us. I think they know what we're up against. They know, look, FEMA's called them. And we were in a meeting and they actually kind of warned us, right? Jimmy and Dave.
You're right.
So they know the pressures that we have on us. I think they're gonna react better, Mike, than they ever have before. I really think they'll work with us. And I'm confident in John as far as the work he's done, that when he turns in work, it's not gonna be back and forth for 2 years and not putting in quality material for them to look at. There's a big difference. They want to see good quality material.
So what do you have to do to pick up that phone and call the court and say, we're coming down here and present this plan to you? What do you have left before you can do that?
we have your vote of confidence.
Oh, they're waiting on us already.
We're ready, I mean.
Okay, so what does it hurt? What does it hurt to give our okay to have him go down there and talk? We're not spending any money doing that.
Oh, we'll probably sell, but, no, that's what I'm looking for. That's what's gonna come out of this meeting, but I'm not sure. We gotta,
That's
I know.
So you don't have to have all the engineering done for this meeting?
No,
The whole next year and a half we talked about?
no, but we have enough of it and we'll tell them what we've accomplished so far and they'll have a good sense of, oh, wow, you guys are quite a bit along here. But this is a great time to talk, to see what else we need to do and add to it. And so, yeah, we've got enough engineering work to do that we can meet with them in March with very little other work.
Okay, so I guess I'm asking, the vote you're gonna ask for is for us to approve for John to go down and present this to the Corps? Or is it gonna be To approve the funds.
No,
to do that. Okay.
no, we're,
We're not.
Okay.
hell, they may not like his firm idea. I don't know.
Yeah, or just, yeah, we have a lot of conceptual things. Ultimately, when we need FEMA accreditation, we also need their approval for the top of the list.
You thinking then by our April meeting that you would have those type of answers, that we know what direction you would like to actually proceed?
I think we'll be able to give you good feedback. It's hard to predict everything,
Well,
you know, but I think we should be able to get in front of them and come out and say, hey, guys, here's making sure, you know, you've heard how we would do this. We can also talk about what if scenarios like that came up as far as Greendale. I'd like to make sure we do Orangeburg first. But I think we're gonna hear something to give you enough. We may not hear the final thing. We may come in April and we may say, well, they want to send us another 4 or 5 things to think about or something. But again, we're not gonna ask for a stamp of approval, but they may send us a short email. I mean, it's happened before.
I would say April, you're gonna be able to come back here and say, hey, we met with the Corps and we're waiting for their response.
Yeah, that's for sure. That's for sure.
Yeah,
Whatever the conversation.
I'll make the motion to give John the ability to go down there and talk to the Corps about this.
Second.
We're not entering into any monetary
Okay,
value.
so we got a first on the floor, a second, any discussion?
I just think we need to make sure that, you know, we keep on it and get some answers back. And I always like to see something in writing, but I know that a lot of times they're not willing to put anything
We
in
may,
writing yet.
we may even take minutes and then send them back for them to approve, so.
Right.
Okay, so I got a first on the floor, a second, all in favor? Anyone opposed?
Very good, thank you.
Anybody got any other?
And by the way, if any of you, between then and now, I know we communicate mostly between Paul and Jimmy, but if some of you have any particular things that are bothering you, some of these ideas, feel free to give us a call. That way we at least have that in the back of our head as well.
So we get a grant, say we get a grant, and you go down there and have a nice meeting with them, and we get an approval, and we got some money flowing in. That berm, for example, I know you said there was an X amount of dollars. Do we not get like bids for something like that?
Oh, yeah.
I was gonna say.
We'll give bids.
It just seemed a little high for me just to push some dirt around. It's special dirt.
It's all, yeah. It's all waiting.
Engineered, it may be engineered fill versus just random dirt, but I understand, no, we will
Everything be
we will
bid out there.
definitely.
We'll have to get a construction.
That's the other thing about this, Greg, is every time we put this out for bid, I mean, me and Heather's talk, this was to get you guys' brain working on our situation. It's gonna have to be, we should be able to tighten up the numbers every time. I mean, even putting the relief wells out for bid.
Oh, yeah, I get it. I know those are built on estimates. And obviously, estimates can be low.
I'm not a fan of engineers' estimates. I'm not. And
I
I told
understand.
John
I
that,
agree.
he's not surprised. I ain't.
I agree.
And when it all counts, I mean, it wasn't that many years ago, Jimmy, that I was guessing that we had a project on Tanner Street for 300 or 400 grand and the bid came in at 1.7 billion.
Yeah, I remember that.
So, you know, I'm a fan of the bid process.
Well, I mean, if it costs us more than $1 million to put a berm in, which is
We could take the shovel.
10,000 yards of dirt.
It all depends on the cubic yard.
Compact,
That's right.
it's 10,000 yards. I didn't mind up on it. It's less than that most likely, but if we can't do that for less than $1 million, then
So,
we should just
The
let
bid
that
process
stand.
is definitely going to help.
Well, we'll have specs for that, you'll see those. And we'll-
Yeah.
it's like any other.
Yeah, and that 2.5 is on the high end, but it was like assuming it was a tightly controlled, compacted clay with trucker density and all that stuff, but it's on the high end, that's what we're trying to do.
Even
Well,
with
we
that, I
got
think we ought to be able to
plenty
do
of
that.
contractors in this area that'd love to do that project.
Oh,
So that won't be a problem.
Right.
I'm like Andy there, hey,
That's
whatever
an
the
easy
bids
project.
are,
It's
that's,
Well,
yeah,
it's
it's a lot of
it's
space
not
out there,
rocket
right?
science, it's science to put some clay
No.
down and compact it to 98%. And to proctor it every 6-inch lift if you
Exactly.
wanted that.
Keep the moisture controlled.
But it's not that difficult. And it's not, we're not building a skyscraper on top of it either.
Right.
Let's not pretend that it really necessarily would have to be at 98.6%.
Right.
Well, it all has, I have a lot of expertise in the control of clay to keep seepage through landfills and all kinds of things. This is a seepage issue, it's not a strength issue.
Yeah.
So you're right.
Yeah, we wanted to err on the
Sure.
side of, overestimating where we could, but.
Good deal.
Anybody got any other questions? Paul?
no, I mean, we covered everything, Jimmy, we wanna cover, that's my only question to you.
And I think
Can I
if
ask
we
can I ask one question about whose money this is? Do you have, the LCD has a kind of bylaws and things about what you do?
So,
So what does it say there?
so what it is, we don't really have bylaws. We have an order from the circuit court, and so we have two of them, one for the Lawrenceburg levy, where we broke off from Lawrenceburg, and then we have one from Greendale. And the Greendale one has this Mitchy mouth, section there that you can only use money derived from the Greendale area or from other sources. And so that or from other sources is the wrench. So I actually read, there's an opinion, which I'll pass out to you guys from another attorney. I think it might have been Ewan or somebody wrote it, and he came to the same calculus I did, is that or other money means that lease money is or other money, right? So, but no real bylaws. It just really, and really, we could go back to circuit and fight that if we wanted to. We could actually petition to change some of those rules if we wanted, but, at this point, I wouldn't go back and try playing around with that, but, it's just for the future.
Anything else, John?
I think that really covers it, Jimmy.
Okay,
Appreciate the time today.
I adjourn the meeting.
I appreciate everybody spending this time here today, I just think we had a really, really good meeting.